Hello everyone, welcome back to yet another CATIA V5 tutorial. Today we're tackling this cool pressed sheet metal part, and as always I'll show you how to break it down into simple manageable surfaces, making the process much easier and resulting in a cleaner, more stable model. Let's start with the front face. First we rename our geoset, then we create a sketch on this plane. We can create a simple line and constrain it. It's always good to have your sketch fully constrained. Then we extrude it in the X direction. Just, it doesn't matter how much. Okay, that looks good. Now we do an offset of this ZX plane. And then we intersect it with our newly created surface to get a line. And this line here, we will sweep. So we're gonna do with the reference surface, select this line as the guide curve, and the reference surface our extrude. 45 degrees should be fine. Okay. Now we do an offset of this surface the other way. Create another offset for the lower surface at the back. Then we do another offset of the ZX plane. Another intersect. And then we do another sweep. So that we can connect it to our lower surface. This time we're gonna go with 50 degrees. I guess it should be fine. Okay, but it needs to be slightly longer. Let's see, 150. That's fine. And now we can fill them together to create our front face. Yeah, 10mm radius seems about right. This one we can go with 10mm, and now it's important that we fill them in the right order, because if we don't, then we might have an issue here. So we're gonna go with the sweep and the offsetted surface first. The order in which you do the operations is very important. I want to plan my operations in such a way so that after this, these two surfaces will intersect in only one point. Actually, the intersection is a line. What I mean is I don't want the intersection to create two lines. Otherwise that would be bad. It wouldn't know how to fill it up. Okay, now we create another geoset, or rather we go into the geoset and rename it to sides to create our two angled sides. Create a sketch on the XY plane. I'm just gonna go a little bit faster here because you don't need to see me constrain it, but basically what you need to do is just fully constrain the sketch to not have it move around. Now, looking at this, I think we need to move this plane a little bit backwards because we need a little more space at the top here. This looks about right. And while we're at it, we extend this this line a little bit so we have more surface to work with. Looks like I created this in the wrong set. No worries, I just right-click, change geometrical set, and select the right one after. Then we create a sweep of this, but this time we go with draft direction because this sketch is not sitting on any surface. So we're gonna go with draft direction, Z component, and this time it's gonna be 6 degrees. Go with the minimum. Okay, that's one side ready. Moving on to the next one. This one we're gonna create one simple line. And we're gonna constrain it, and afterwards we're gonna end the sketch here because we're going to include the other surface, the small angled surface that is perpendicular to this one. We're gonna include it in a separate sketch and include it in the side. So we create another line, fully constrain this one as well. At least the distance to the horizontal plane. That should be good enough. We go with sweep with draft direction as well, but this time it's a very shallow angle, so 50 degrees or something like that. Probably a lot longer too, so that looks fine. We're gonna fill them together, and this will be our left side, or rather the other side. Yeah, that looks good. Now we can go to one of the other geosets and rename this to final part or something. And here we're gonna fillet these surfaces together. Oops, almost made the same mistake again. I need to put this fillet in the final geoset. Okay. Um, 10 millimeters should be enough as a radius, I don't know. It really depends on the material. Okay, 10 millimeters again. Now we go back to the construction geoset, rename one of them to Weld Flange. We're gonna go with Weld Flange bottom because we're gonna split it in two and start designing our flange. We create another sketch, draw a line. This is gonna be our base surface, basically our base bottom of the flange. We constrain this line as well. Okay, I'm gonna show you something here. How you draw this part really depends on the function of it. So this profile, from what I can tell from the picture, looks like this. And it looks like this because it probably has something here and something here. So some other surfaces that it needs to interface with to weld it to, and probably another sheet that goes something like this. So in fact, that means I need to constrain this line, this sketch, from here to here. This is the important distance that I need. Right, so again, I constrain the two ends of the line, and then I extrude the line in this X, yeah, it's X direction. Okay, looking at this extruded line here and the picture, it looks like this shouldn't really cross that angled surface on the other side, because that one needs to be a little bit higher up. That's part of the other weld flange, so it should be a different Z height. So I'm gonna modify this a little bit, just like that. Then I'm going to sweep the ends of this extrude surface 45 degrees. The length doesn't really matter because it's gonna be really small. Okay, that's one end. Now the second one. Good. Then I'm going to offset this surface because this is probably gonna be a function of this other surface to maybe 1.5. It's one material, one sheet thickness. The thickness being from the other potential part. Then I'm gonna extrapolate this, go with point continuity, extremities normal, and continuity curvature, so we can get rid of those ugly lines. Right, now we can start filtering this. Start with the first surface and the sweeps. Front one, then the rear one. Okay, that looks fine. And then we're gonna fillet the offset to this surface. Okay, that looks great. Now, there is another bottom surface here, a little extra depression inside the flange. So we're gonna create another sketch and do basically the exact same thing that we did for this one. Okay, sweep 45 degrees up, that should be alright. Then we fillet this one. We're gonna create this as a separate surface, 5mm radius, another sweep, another 5mm radius. Make sure you get the orientation right. Then we're gonna sweep. Then we're gonna fillet these surfaces together, and that's literally the whole bottom flange done. I'm gonna create another geoset here, call it front flange. This front flange is gonna be really simple. It's just an angled line extruded in X direction. First we make the sketch and fully constrain it like before. 140. We're gonna extrude this all the way. One particularity here is that we need to create that rib there that looks kind of like a drainage channel. For this we will create two offset planes, and we're gonna intersect them to the extruded surface. And then we have, as a result, we have two lines. Looking at it, I think these lines are a bit too close together, but we're gonna deal with that later. We create one offset of this surface, which is gonna be the top of the channel. Yeah, definitely these are too close. We need to move them a little bit further apart, like that. That should be fine. Okay, now we do a sweep surface with the reference surface. Select the guide, we select the surface, the base surface as the reference, and we sweep them inward. Okay. Then we fillet the surfaces together. 5 mil should be fine. Another one. Yeah. Good. And then we fillet the channel to the base surface. Yeah, the direction looks fine. Okay, good. Okay, good. This looks really well. These two geosets, I don't really like them like this. I'm gonna move them together in another geoset and call this one Weld Flange. Yeah, that's fine. And here in this final set, I'm going to fillet them together. Yeah, not gonna worry too much about the actual size of the radius, because you can always increase that if you're not happy with it. Okay, in the final geoset, here we're gonna need to fillet our base surface, or whatever we call it, to the weld flange. 10mm radius, and it's fine. It's already starting to look very similar to our part. Next, we need to create another geoset called depressions, because we're gonna do the depressions now. I know you're probably tired of hearing this, but it's good to have separate geosets for everything. So we create an offset from this plane. This is where the top of our depression will be, and we create a sketch on it, which is just gonna be a simple circle that you constrain really well to the axis system. Okay, we fill this circle in, and then we create a sweep based on this circle and the reference surface being the recent fill you did. So 9mm doesn't really work, so we go with 96. Okay, it needs to be sufficiently long enough to exceed all the surfaces. We fillet the fill to the sweep. Let's go with 10mm, see how it looks. 5, yeah, that looks good. Okay, we do the exact same thing for the second depression. Yep, that looks good. And the last one here, it's gonna be kind of like a cylinder in there, in that radius. Luckily we have this sketch already, and we create a point on it, which is gonna be our axis for the cylinder. Then we create a plane, we choose parallel through point, select the ZX plane as a reference and the point that we created. We're going to create a sketch on this, and it's going to be a simple line at an angle. Good. Now we do a sweep The sweep is going to be basically a cylinder. We select this option here and we go with center and radius. Yeah. Okay. Let's go with 20mm radius because it's pretty big. Yeah, that looks about right. Okay, now we want to fillet this to that shape, but we want to do it before we put this weld flange. So we go to the final part, we go to the fillet 7, it's called there, the one before, and here we use one of my favorite commands. It's the insert mode. We check that and then we do our fillet, selecting the first fillet as the trim 1 and trim 2 are newly created cylinder. Let's see how much it should be. A little bigger, should be a little bit bigger. 20 seems fine. Let's reduce the cylinder diameter as well. Yeah, that looks good. Okay, now if we unhide the last fillet, we see that it's neatly blended into that. That's the beauty of parametric design. Okay, now we do the other depressions. We fillet them to the surface as well. Make sure we have this right support orientation. That's fine. Let's go with 10mm for this one. Yeah, good. The exact same thing for the second one. 10. Yeah, that's good. Okay, looks perfect. Now we create another geoset for the tab. This is my least favorite part. I hate creating tabs. So we call this geoset tab, and here we're going to do an offset of the ZX plane as well. And we're gonna do it somewhere around here. Yeah, that's fine. Then we're gonna intersect this plane, but we don't want to intersect it with the finished surface. We want to pick something more basic, like this one. We intersect that, we get a line, then we intersect the line with this other plane, the YZ plane, and we get a point. This is our center point in the line. Then we create 2 points. One based off this one is going to be let me think, 10mm. Yeah, okay. And then we create another point. We can just copy this one, copy paste, and then reverse direction. It's much faster. Okay, now we split this line with the 2 points and we get our tab width, and then we extrude this down in Z like this. Doesn't really matter the length, but we'll just make it a bit shorter. Yeah, we'll just keep this length, the 15mm tab. It will be controlled just by this, not by any other trim. Okay, now we do the more particular fillet, where we select our latest surface and then select the tab, but we select minimum here on the extremities. Make sure you get the supports right. Okay, preview, and it's going to create this tab like that, exactly like that. And we're gonna make sure we cut out the material next to it. And to do that, we need to create another geoset. It's the trim geoset, and in this set we're going to have multiple geosets for the back, side, and front trim. So we're gonna start with the back trim, because we're already designing this tab. Here we're gonna have a sketch on the XY plane, and now we project these 2 points, so we have a starting point. And now it's kind of like a tedious process where we design these notches on the left and right side of the tab, and we make sure we constrain them really well. Also, we have this rearwards level. Once we finish the sketch, we extrude it in Z, and that is our rear trim or back trim, however you want to call it. Okay, another geoset here in this trim set, and we called it side trim. The one on the right is very simple, just a simple sketch and just a straight line at a certain distance from the origin. This is really basic, and extrude it up. The other one is a bit tricky, but yeah, not that much. Create another sketch, then a quick surface here. It's basically two straight surfaces with a step, yeah, and extrude it up. Something like that, yeah. Now, the front trim is a little bit tricky because we want our corners to be perfect. And to do that, we, as you would expect, create a sketch on this plane and constrain it really well. That's fine. Extrude it in Y direction. This is, yeah. But now what we do is intersect this this surface here, and we want to intersect it with the bottom flange, and then we extrude this in the direction of the bottom flange, so something like this. That way, when we fillet this to the rest of the trim, the radii that way we can control the radii to the exact value we input, and it's not going to be a weird shape variable or anything. Now we need to extend these trims a little bit better so it intersects the front trim, and now we just fill them together. And this should be a little bit bigger. Select here extremity smooth. Yep, that's fine. Yep, okay. And the last one. And that looks perfect. Okay, go back to the final part and trim our latest surface with this trim surface. And we have our nearly finished part. We noticed here that we have these sharp corners that we don't really want. We kind of skipped on the trim for that. There's a really quick fix to this. You just create the corner by selecting the edges. You don't need to have the trim elements selected. It's better that way. I need to fix this in the first one. Yeah, that's fine. Update. Okay, I get a little error because the corner one is no longer extending that far. Yeah, we just reselect that and that's fine. And then we do another trim with these two wireframes. Okay, good, perfect. And we can go ahead and hide them. We're not gonna need them anymore. Now for the final step, the holes. We'll start with these round holes located in these depressions. I'm gonna start by creating a point as a circle center on one of these depressions over here. Then I'm gonna create a line normal to this surface at this point. Now I create one for the other circle. Then I quickly do the same for the other depression. To define the holes, I'm going to do a cylinder as a sweep with center and radius using the normal curves. We create this cylinder here, it should be a little wider, and the other cylinder there. Yeah, that's fine, click OK. For the other hole, this is a slot. We have this feature here in the sketch. We just constrain it to whatever the specifications are. Obviously, there's no specifications in my picture. That looks about right. Then we do another sketch on the YZ plane because we need to define this hole over here. This is kind of weird shape. We would probably have some specifications for this hole, and it's just gonna be a rectangle that I'm going to extrude, and then I'm going to fillet the edges afterwards, so I don't spend a lot of time doing this in sketch mode. It's kind of tedious. Okay, that looks fine. A little more, I think 10 millimeters should be good. Okay, extended this too much actually. It doesn't need to cross the plane, the symmetry plane. Okay, that's good. Not actually symmetrical, but you know what I mean. Then we do another split, our final surface with the holes. Click OK and hide everything. switch to the part body workbench and give the surface a thickness. The other way, 2 millimeters. Okay. Hide everything. Hide everything we don't need. And that's that. Perfect part. However, we see that this part is a bit wider than our reference picture. So this being a parametric part, we can just go back to the sketches where we design every element, change it, change the side, change the holes, change the trim really fast. It's really easy to do. That looks a lot better. Just one more thing is the drainage channel that I'm not really happy about. This causes a bit of an issue, but I guess it's because, yeah, we need to move it a little more. Yeah, that's fine. Perfect. And this little circle here, this little depression, should be inside the shape. Okay, move this a little more inside. Yeah, that's fine. Update everything, and within seconds the part just automatically updates. That's beauty of parametric design. And that's how you design this part. Don't forget to leave a like and a comment if you found this helpful. It helps me a lot, and see you next time.